too. I try to record these meetings for everybody so you can actually download them and watch them after the fact. So this is where the plane's going to take off. It's going to climb to its cruising altitude. So say if you're out there and you've got changing wind directions and you kind of want the plane to determine its own best course of landing, you want to do this in a wide open area. But there is an option for doing that. So if you click this button that says Add Sector, the plane is going to determine on its own, actually you got to add all of them. The plane will determine the best course or the best direction to come in and land based off of the wind if you select them all. But we'll just use this one because I knew which way to go. So on this flight, the people that ran the quarry had a KML of their boundary for their site. So there's two different ways that you can set up the flight lines. Go ahead and turn this off. You can put a polygon around it and then just simply stretch it to where you want it to go. And that's all well and good. But if somebody's given you a boundary of the area that they actually want flown, we can do this with some degree of purpose. So he gave me a Google Earth KML. So this little hidden gear down here, which kind of looks like something you'd see from, if you click on that, you can go right here to load mission area from KML. It's a pretty slick feature. So if I save this in my documents, and it's called the Pottsville Quarry. This is Pottsville, Tennessee.
Yes, I just look over at something on the table. There's a...
All right, so if I zoom out here a little bit, get my mouse to work. If I zoom out here a little bit, we should be able to see that KML. And if we look here, you can actually see that the flight area is extending beyond my geofence. So if I go over here to my little settings tab, I can go in and actually change that working area radius, which defaults to 1,640 feet. I'll go ahead and make it about 3,000 just to make sure that it fits.
Yep.
So panning down here a little bit, as you can see the flight line, there's still one touching the geofence. So if we launch this plane with it still touching the geofence, it's going to want to sort of loiter over the landing spot and wait for more information. So I'll make it just a hair bigger. There we go. So now our entire flight line is outside of or inside of the geofence. So this purple line that goes through here, that represents the KML that they emailed me. So the product that we fly is actually going to be what they wanted. So using that KML, it created a flight line. I've got a 70% overlap by 75. If I make this 75% by 75%, I think it broke it into two separate flights. So if I wanted to keep it to one flight, I can do a 70% by 75% overlap. And on this particular flight, I'll pull up the data afterwards, that because we flew it this direction, it left some holes on this high wall here. That high wall, there's actually, this area has been disrupted as well. So the high walls that ran pretty much parallel with the flight lines, there were some sporadic holes left in it because I didn't fly intersecting flight lines. So if you're ever wanting to know where that's really beneficial, that's where it's really beneficial is on high wall data. So that being said, I can go ahead and upload this flight plan to the plane. Oops. That still looks like it's within it. Yep. Pretty big flight plan. It says it's going to take it 37 minutes and 25 seconds. If I was concerned about obstructions, this was a pretty flat area. But if I'm in a mountainous area, I can import that Google Earth surface terrain model. I can re-elevate my flight lines and hit the OK button, and it'll upload elevated flight lines. So there's areas where this particularly isn't that important, maybe in agriculture where you're in a flat area. But if you're in the hills of West Virginia or down in southeast Kentucky or Pennsylvania, these are pretty important things to make sure that you check. Otherwise, there might be spots where you exceed your 400-foot elevation threshold or 500-foot threshold as you're flying over a valley. So this particular feature is nice, just making sure that you maintain pixel resolution, but also staying 400 feet off the ground and not crashing in the mountains. So I'll double check this flight line in Google Earth to verify that we've cleared everything. So if I pan around here a little bit, I can see that the terrain doesn't interfere with the flight lines. And where you'll see that is that the higher up elevation purple line will disappear, and you'll just see this purple line below it crashing into the mountain. And that's not what you want. And there really was no hills here, so it was kind of a moot point. So flight lines look good. They're all elevated correctly. You can see that there's a little change in the flight line elevations there, but there's no hills coming into the view so we're good to fly. So I'll go ahead and start the simulated launch, and this unit's equipped with a magnetometer and an inertial sensor. It detects that shake. You shake the plane forwards and backwards. And as the motor starts up, you just kind of lean forward at a 45-degree angle and let go of it. So I'll go ahead and fast forward this. And while it's flying, it's telling me mission's out of working area. So I'll make this 3,300 feet. And now I can tell it to resume start mission. So it recognized that my flight line was still a little too close to that boundary, and it loitered over the landing spot and waited for some more instructions. So to set a photo target, so if we wanted somewhere in this flight area to pick up a oblique shot, let's say this high wall, for instance, I can say I want to add a photo target right here, right there over the high wall. And I can adjust the pitch of that oblique by moving this arrow in and out. So that's a steep oblique. And if I want to change the direction of it, the rotation of it, I can just rotate it around so it determines which direction the plane will come in and take the picture. So if I'm ready for it to go take the oblique, I can just click the Go To button. It'll come in, take the oblique, it'll dive at a negative 50-degree angle, and then it snaps the oblique and rolls on, and it dives at negative 50 degrees for and you see it just takes over the mission again. It's without any further interface. I'm not touching any buttons. It just went ahead and finished it. So that's useful on capturing the fronts of buildings, high walls, things that you actually want to see the front of rather than a top-down view. So this is a 27-minute simulation. I don't know. I'm not going to let it do the whole thing. The waypoints tab shows us what waypoint elevations that we're going to be flying to. So we have 371 feet, 404 feet above altitude. So you can see that there's some change here on the site that's forcing the plane to elevate its flight lines. So what I'll do, rather than watching grass grows, I'll go ahead and tell this unit to come in and land, and then we'll proceed to the next part. But this is the long and short of it. It's pretty simple to plan flights. Just need to be cognizant of obstructions and hills and the terrain that might interfere with your with your flight.
Set 420.
So the plane's landed, and if you want to go ahead and download flight data from it, you use this flight data manager. Of course, I don't have my plane hooked up, but right here is that little flight there, and I think there was one maybe the day before. Yep. So where I don't have the plane hooked up, I'm going to go ahead and do this a bit more manual. I'll just call this my demo, and the flight log is right here. We're just going to import the autopilot file. Nice and quick for you here. Am I missing anything? Does anybody have any questions at this point? And I'm zipping along pretty quick, but I'm just trying to leave time for Jim at the end of this. Golly. Whoops. Normally it doesn't seem to take this long when you're standing with it in the field. I didn't request a flight log to be imported, even though it's importing something. All right. So it's asking where to import the pictures, and I don't have the card plugged in there, but I do have it on my hard drive. And just select where the pictures are. And there's the geo tags for them. So this was done with an RTK unit, and something that's pretty neat to know about the RTK units. It operates a couple different ways. You can use it with a VRS network type connection, so relying on some sort of Wi-Fi / cell phone connection to an RTK network. It'll get its corrections that way, or you can hook a local base to it. And some things to pay particular attention to: the unit likes to work in WGS84, so it gives you a couple options when you connect to it. So you can tell it that your base is sitting over an unknown position, and subsequently you can correct the vectors, or basically the baselines between the base and the plane, subsequently after the flight, which is a pretty nice feature. So if you don't have the base sitting on a known point, you can adjust everything after the fact. But I'll tell you this: if you do have it sitting on a known point and you plug the coordinates into the base and you plug them in incorrectly, I can assure you you'll be fighting with it. So exercise caution if you're using an EBRTK. When you're plugging in base coordinates, just make sure that whatever it is, if you're working with 83 or 27 coordinates, that you have a true WGS 84 latitude and longitude value for that site. Or else you could be going back and doing ground control. Wow, this is taking a little while, a little longer than I expected. So what I'm going to do is move on to Post-Flight Terra 3D real quick while this thing is importing pictures from my hard drive. And a couple of things that some folks didn't get to see from one of my prior webinars was using ground control in the Ray Cloud editor. And it's a pretty nice feature. If you do this initial processing, you go to process and local processing. If you go ahead and run the initial without running step 2 and step 3, you can do your control calibration with the standard EV quite easier. And these are already done, but I'll just go through the basics of how to make it happen. So if I go to the Ray Cloud editor, not the Mosaic editor, the Ray Cloud editor, and this is an old dirt run strip down in South Carolina that was being redone by the gentleman that owned it. It was a private air runway. They went down and they put some control on the ground. And if I go here are my my control points. Like here's the easting, northing elevation of those individual control. And all you have to do is locate it in the first 2 pictures. And once you've located it in the first 2 pictures and you click the optimize button, it takes it about 10 seconds, and it goes and finds it on in all the pictures that it exists in, that target exists in. So I had located it in 6. It found it in 2 more pictures. So all I have to do is go and click on it there and hit the apply button, and now I have it in 9 pictures. If I go to the next control point, I've located it in 2. I can click the optimize button. So I did it in 6 pictures thus far. We'll see how many more the software finds on its own. I didn't find any more on its own. I'll go to the 3rd. So previously we had to actually go through a large picture and find this point, and you had to find it in at least 6 photos. So it got to be a little time consuming. And with this Ray Cloud editor, there's only in 5 pictures there too. And the Ray Cloud editor makes it real easy to go in and locate these now. So all you have to do is find it in 2. And once you found it in 2 and you click the optimize button, it'll find it in all the other pictures that you didn't find it in. So it found it in 5 here. And it found 2 more pictures that the control point existed in that I didn't know. Yeah, it's a little too blurry, a little too washed out. But anyway, there's 7 pictures there. I have it located in 5 here that I did it manually, the difficult way. So I can already see that it exists in more than that, and I didn't find it in the other pictures. So if I click the optimize button again, the software will automatically go in and find it. So there we are, 7 pictures. If I go back down to those ones that I didn't locate, we can see that they're targeted now, and I'm ready to process it. So after you do all that, if you add more ground control points, you can go up here and say process and re-optimize, and it'll take it about 2 or 3 minutes to recorrect the whole entire site with that added control. But I am a little limited. Well, I'm going to try to hurry up here a little bit. So I'll go ahead and pull up the actual point cloud that we did. And if it seems like there's a little delay, it's coming from an external hard drive that's plugged up to my computer. It is USB 3, but it's still an external hard drive. So bouncing back to eMotion 2, our pictures did import. They're all geotagged. There's no significant offset, which if you see a big offset here, that typically means that the BBX file, the autopilot file, does not correspond with your picture file. But in this instance, it says there were 228 geotags and 228 pictures with 100% match and 0.26 seconds of offset. That's camera time versus GPS time off the plane. So I'll click the next button. This is kind of slow, so I'm going to bounce back to post-flight Terra 3D again. So again, this is I'm going to turn off the cameras and the rays. This is the runway that this gentleman constructed on his own time with his own money. Looked pretty good. Here's our control points. You can even see the orange paint in the point cloud here. You can see where they marked it. One out here, it looks to be in a good spot. So what I did for them, they thought was pretty neat, is I drew a line in here, an animation, a trajectory animation, by using this little camera icon up here. And I went around the site and just recorded viewpoints. So if I click this playback, I tried to make it like I was taking off. I didn't do such a great job, but it does have a nice playthrough feature that lets you produce a nice visual animation of the point cloud. So looking at this site here, there's some things that would interfere if we wanted to make a digital elevation model, like trees. You can see that there's, lots of dense green stuff here. So if I go up to my point cloud, and it's turned on, and you go up to process and say compute point cloud classification, it's still in its infancy, but it takes it about 10 minutes. But I went ahead and done it already. So if I go ahead and turn off the point cloud, really I probably want to turn off the tie points too, the photo tie points, that is. Still see it left some data in here. Whoops. Well, and it took a big chunk of it out. There's the data that it removed. If I wanted to go in and manually erase it, I can click on the little point cloud edit feature. And I think it's you hold the shift key, draw a line around it, and then you can shift key, draw a box around it. Oh, there it did. It got it out of the densified one and not the reclassified one. So it got rid of that structure that was there. Or if you just want to get rid of these trees manually, get it in a bit more of a perspective view here. I can hold my shift key, draw a box around it, and I can hit my delete key, and they're gone now. So there are some manual edit features inside of Post-Flight Terra 3D that will help you speed things up a little bit and get rid of some extraneous data. But there's other software out there that's been around a while that is quite capable of getting rid of extraneous information of trees, buildings, cars, bulldozers, that kind of thing. So going back into Post-Flight now, it's still creating the project. And it's going to geotag those pictures. Of course, I already have this done, and it was done with the EBRTK, so there is some method to this madness about why the RTK unit's pretty handy. So I'll go ahead and close this project, and I'm going to, oh, I didn't want to save that. You know, that particular demonstration, the Aeronautics Administration down in South Carolina wants to use that for minimum clearances at the end of runways for trees. And they actually imported that data into ArcGIS and projected a plane, and not an airplane, but like a 45-degree plane from the end of the runway. And the points where it intersected trees where they knew where they needed to remove things. So if I go here and just to illustrate where the EBRTK is pretty nice, access denied. So I'll go ahead and open up the geotag accuracies of the flight. So looking at our photo properties, a standard EB unit is going to give us accuracies here in the meter range, 1.5 meters, 2 meters, 3 meters. What's really nice about the RTK is they're already geotagged down to a centimeter. So when you process this data, your georeferencing on your pictures is already corrected to a centimeter. But better yet, it takes the software a lot less time to overlap photos that are already kind of overlapping. It doesn't have to move them very far to find common key points from picture to picture. So this is a pretty good illustration of what we see with the EBRTK specifically hooked to a local base station. And with an NTRIP connection, periodically you'll notice that there'll be a shot in here that just wasn't fixed. Maybe you had a hiccup in your data connection to a network, and you'll see a picture that's, meter and a half, 2 meters, a minute was in float. And not that it'll affect the quality or the integrity of the orthomosaic, but in the statistics table that displays the relative accuracy of the georeference of the map, it'll average in that RMS of that float shot, which is not going to be good. So it'll pull its key points from the picture that was fixed, but it still applies that horizontal accuracy to the overall mean of the georeferencing accuracy of the flight. So if you have a float shot in there, you just always recommend you just turn them off. If you should have good overlap, shouldn't need the picture anyway, but it gives you a nicer looking statistic at the end for your georeferencing accuracy. So moving on, back to post-flight Terra 3D, it created everything. It made a KML of the flight and all the geotags for the pictures, but it also made the post-flight Terra 3D project. You have to use this software for downloading if you want the data to go into post-flight Terra 3D for processing. So, any questions at this point? So I've blabbed a good bit. So what I'll do is oh no, it's right there. Oh, okay. I'm going to close this out and I'll pull up the final product there of this site. You can't just switch projects in post-flight Terra 3D either. So this was done with an RTK unit, but they had some panel points out here from the aerial company that we brought in just to check things with. So I'll move on to Array Cloud Editor. Project loading up here. I'm going to go ahead and turn off these orbs, the pictures. And off those manual tie points. Still loading. Huh. That's terrific. This must not have been the one. Turn off these automatic tie points and turn on the point cloud. There we go. This computer is equipped with 16 gigs of RAM too, so it was a fairly decent sized site. Is there anything anybody has run into that they kind of have some questions about? I had one customer today that ran into an issue where he had a pitot tube calibration problem. I don't know if anybody's run into things like that they might have questions about, things that we can resolve. without having to actually send a unit in for repairs. Things you should be able to do directly on site. So we were able to download the calibration information from his plane, and Sensefly gave us a new one, and we managed to fix his unit without having to send it in. I don't know if that's something that the rest of the world's run into or not. Almost. It's a pretty big data set. There we go. So there's our site, and as I referred to before, the site where we flew it parallel to this high wall, there is some data missing. Perpendicular flight lines would have kept that from happening, but that's ultimately how it happens. If you want real good data on this side of the high wall, you got to fly intersecting flight lines. This right here is the original pit, and it had water all the way up to the big empty spot. They're trying to pump it out, but it's such a flat area that it just kind of runs right back into the quarry again. But just some of the features, or real quick features here inside of post-flight. If I want to do a volume, I got to have the filtered cloud open. I hope this doesn't take a couple more minutes here. Again, if I wanted to delete things out of here, I can turn on my point cloud editor, hold my shift key, and then just delete things. Same way with this lone excavator in the middle of the pit. So we should be able to rotate now and look at it, and it should be gone. And the same way with those buildings or anything else. The site, they referred to some of this stuff as manufactured sand, and that's what I'll work the volume up on here once this densified layer finishes loading. So some other neat things about this software, if this site had been flown before with LiDAR or something to that effect, we can actually import, it's not letting me click on it right now because it's loading, but I can import a secondary point cloud. So if I were trying to figure out the difference between one LAS set and another, it'll actually let me calculate the difference between the two now, which is a feature of the newest version of Post-Flight Terra 3D. That's something else that will affect our volumes, all the belts. Okay. Go ahead and get out of this mode. Okay, it did it. All right, so to do a stockpile volume in Post-Flight Terror 3D, it's pretty easy. You can use this little guy right here. So if I want to do a stockpile volume, all I got to do is click this, stockpile volume, and wherever I click here on the ground is going to be my base. So you'll have points on this where you actually go below the base if the loader's been pulling material, pulling it and pulling it and pulling it. It's really probably not going below the base. All right, so if I'm happy with that perimeter, I just right-click. It creates two surfaces. The red is the area in the cut. The green is the area in the fill, so you can see where the stockpile data actually goes below that baseline that I drew. So if I want to see that volume, over here on the right side of the screen, there's a little arrow. Shows me the stockpile on the individual pictures, and it gives me the cut volume, and this is in cubic feet, so 27,240 cubic feet. There's 7,000 square feet of area. So there was a little bit of fill volume where it, just dipped below that line, but for the most part, 27,240.25 cubic feet of gravel. So does anybody have any questions about Post-Flight Terror 3D? And I'm going to go ahead and move on and let Mr. Carlson take over. No? Well, cool. Jim, I'm going to go ahead and make you the presenter. Are you still on?
I sure am.
All right.
Can you hear me?
I can hear you, Jim. I can hear you just fine. So I went ahead and switched over to you. If you want to go ahead and there we are.
Okay, this is, I'm in AutoCAD 2015 with Carlson 2015. And I asked Pete Orbovich, who works for Cairney's with Chris, to send me some data so I could do a little demo at this GoToMeeting. And what is needed is just the TIFF file, georeference. This is the TIFF file, and this is the georeference TFW file that comes directly out of Post-Flight 3D. And you can see that uncompressed, it is 3/4 of a gigabyte. He also sent me the point cloud file, which is a LAS LiDAR file. And he also sent an ASCII file, X, Y, and Z, space delimited file. So I could use any one of those, any of these two right here to create surface models from. The first thing that I brought in was the image right here. And that is done inside of AutoCAD Map using the map insert command right here. And I've already done it, but you just pick right there, and it will take a little while for a 7 or 3/4 of a gigabyte thumbnail to load, but there it is. And it shows you the file and its coordinates. I've already brought it in, so that's that. Similar to what Chris showed on in Post-Flight 3D, I was just going to do a little contour map of this area and do a volume. While I was waiting, I decided to see how long it would take to make a contour map of the entire site, and it took quite a while. It took 30 minutes this morning, and I'm just going to follow that with layer. And this is 2 million plus points. Took about 35 minutes inside of Carlson Point Cloud to contour this, and then I just brought it over. So I could obviously do a surface model of this right here, but what I'm going to do is just show the process of slicing and dicing, I call it, the point cloud to create a smaller point cloud of these stockpiles right here, and then to essentially export a Carlson tin file that I can then use in Carlson Civil to contour and do volumes with inside of the AutoCAD environment, as opposed to how I made these contours, which I did inside of Carlson Point Cloud. So I'm going to do layer off and just freeze that right there. Let's go up to point clouds and pick Point Cloud Manager. Just for those that are familiar with Carlson, how do I get to the Carlson Point Cloud product? Under settings, we have the Carlson menus. Most people are familiar with the Carlson Surveyor Civil menus, Hydro GIS. And down here we have a Carlson Point Clouds menu, and I already have it loaded, but I'll pick it. And I'm going to come down and pick Point Cloud Manager. And we're going to go to Open. And this is the file that I created this morning. And it comes up. This is the cloud. And I'm going to go down here, pick View to look at the point cloud. That is the LiDAR file. Let's see over here. Let's go to View. Well. Well, I wasn't anticipating that. Let me get loading. All right, let me go to clouds here, and let's do import. Import a new LiDAR file. And here is the LiDAR file. We'll go to details. Here's the LES file, and it's 71 bytes. I'll pick open. It's importing, creating a new cloud. So this is how you actually create a new cloud inside of Carlson Point Cloud. We store the point clouds as pod files. You can see I just brought it in. This is the file right here. And it's 2 meg of points. No intensity, but it has position, obviously, X, Y, Z, and RGB color. And at this point, I'm going to come down here and create a new view. And we're going to do 3D and color. Click OK. And similar to what Chris was showing inside of post-flight 3D, here's the same point cloud that was created in post-flight 3D inside of Carlson Point Cloud. And this is 2 million points. And I can just zoom around, and obviously these are the stockpiles that I want to look at. So it's a nice, powerful little editor, or screen viewer, I should say, that you can manipulate a lot of data, and it could be a lot more points than 2 million. Right now, you can come down here, you can change the vertical scale, so you can go to different vertical scales. I'll just pick there. Let's go back now. Pick from front, top, and zoom extent. That's how I kind of get back to where I want to go. Let's go to action now and create a, let's actually output these 2 stockpiles right here. So I'm going to go to action, and it says polyline. I don't actually have a polyline, so I'll just do perimeter. And I'm going to just do left click to create a perimeter. And you can see if I do end mode right now, I can do invert, and that captures everything but what I selected or enveloped, or I can do invert again and just say I want to create a cloud of the area of interest, those 2 stockpiles. So I pick cloud here, and it creates a second pod file for just these right here, and I'll just call them STK12. And that's what I essentially call slice and dice. We have so much information that most of the time you just want to work on a street, a runway, stockpiles, and that's pretty much it. So I go to end here, go back to project, and let's go ahead and save this. Okay, it's done. This is ghosted, so it saved it. And we're going to go down to properties right here, and you can see that instead of 2 million points, I have 50,000 points, so that's plenty enough. Now I can go to, let's close this class, that view. Let's go up to stock 1 and 2, go to view here, and create a new view, color, and we'll just move there. And again, there's the view of that, just that stockpile right there, of 50,000 points. And again, to get it to plan view again, I just do those 3 picks right there. So we don't do volumes inside of point cloud, but I certainly can contour if I want to. I can say extract contours, and right now I'll do 1 foot contours. It's that tells you the minimum elevation, 32, and we'll just reduce vertices fine. Shouldn't take too long. 50,000 points. Sort of block at a time. Okay, there's the second block, and I think it's now going to contour this area. As I said before, I usually don't contour inside of Carlson point cloud. I just export a Carlson TIM file from Carlson point cloud, and then I contour inside of the AutoCAD environment, which most of us are very familiar with. And similar to Chris's demonstration, when you have a lot of data, sometimes it doesn't work as fast as you would anticipate.
I think it's the go-to meeting, Jim, because my computer doesn't normally run that slow.
Yeah, that's probably true. I'm about to cancel if it keeps this up, because we're already at 2 o'clock. It's already an hour into this meeting. Let me let it go through this one more time and see if it starts to plot the contours. But you saw the contours that I brought into AutoCAD before. It did take 35 minutes to do 2 million points and only a few seconds to plot the contours on the screen and then in turn dwell in the AutoCAD environment. Probably because of my familiarity with Carlson Civil and AutoCAD, that's why I prefer to export a TIM file and then bring it inside of Carlson Civil and just contour on top of the aerial photogrammetry file. Okay. I wonder if I'm doing the, all right, at this point, one more screen, and I'm going to just, points is not many points. I could have done that in seconds inside of Carlson Civil. Okay, I'm going to just do cancel, do end mode, go to project. come down here, hit this guy right here, do create. This makes the TIN file. We'll call it a CTR-1-2. 3 million points. We can obviously go down to the lowest, 250,000 points. Let's see how long this takes. Okay, how fast was that? That was pretty fast. Now I'm going to go down to mesh. Here it is. And we just want to export it to a, I'll just call this FTK1-2. And there it is. We have, I'll say changes yes. And come back here. And we're going to go to the Carlson Civil menu. And we'll do contour from A10 file. And we're going to no including exclusion. We'll do 1 foot contours and 5 foot index. Label contours, sure. We'll label contour ends. Now we'll just do the index 1 label and come down here. And I think we're pretty good. Simplify, sure. Like that. Okay, and there's the TIN file. And let's go up here and do display order and do send it back. I'll just erase that image. Let me see where this thing drew. Let me go down here and do draw surface, draw triangular mesh, and hit T-mesh, and do zoom extents. Okay, and there it is. And I'll do L-del. So that's where the T-mesh was. Oh, and there's my contours. Okay, and kind of curious what are the coordinates here? ID. Just curious. Really have to set a grid, but I'll go ahead and do it anyway. State plane, those are we type units real quick. Down the decimal, everything should have been correct. Anyway, at this point, I would do PL for polyline and just draw a polyline. Anyway, you get the idea. At this point, I do see to close, and I want to do PL for polyline. And do a quick profile through the surface model. And I'll do P for polyline and pick this guy right there. And there it is. Just shows you the surface model and cutting through it. So let me go back to point cloud. And do open. Let me open up another one here. I think I saw Mike Gray from A&R on this. And this is a file that was sent to me by Mike Gray. And I'm going to come down here and do view. Let's go zoom extents. And here was a file that Mike Ray, using the EB drone, flew this site right here, but he had quite a bit of trees and the like, so I used polyline, because I drew in AutoCAD on top of the aerial photogrammetry to bring it in and draw in here. And then I used that same feature that I did before here in action, except I used polyline to select the individual polylines and then remove those from in other words, I used this, inverted, and did that with several polylines at a time. There's so many polylines that I did it in several steps. And then when I was done, I actually contoured all the data, and I'll just bring up that drawing right there. I think it's this one here. And there it is, and you can see there's the contour map plotted on top of the aerial photogrammetry map that came from the EB product. So all in all, once you have the aerial photogrammetry from the EB flight process with post-flight 3D, you can bring in the aerial imagery inside of AutoCAD using the map insert command, georeferenced, and then using Carlson point cloud, similar to Sensefly. I saw that capability where you were contouring and doing volumes. You can then bring in the data, create a Carlson tin file, bring it in here, and contour using AutoCAD entities for both inclusion, exclusion perimeters, and also for doing volumes. And if I, just out of curiosity, let's do quick profile again here. And let's see if I can locate this one here. Try all excluded. And where's that down? It's right here. Let's go up this. I didn't want to do that. I just wanted to pick a starting point. I will do this. How about that? So it's going through the 10. This is actually, I used all the data, so it should take a little while to load up this 10. And there's the 10 file. And again, that was generated directly from the point cloud LiDAR file and brought into AutoCAD and essentially created a contour map, and you could do volumes from this, pull profiles, road design, and the like inside of AutoCAD. So that was a real brief presentation of how to create a contour map and do volumes inside of Carlson Point Cloud, and then superimpose the contour map on top of the point cloud. And that's pretty much it. If anybody has any questions, I'm here for any, if you have any questions I could possibly answer. Hello?
Hello, Jim. Yeah, I really appreciate you sitting in. That's a huge site right there that you're looking at. I didn't ever think to actually use a polyline to exclude areas obscured by tree cover. That's very nice. So, excellent. I appreciate everybody sitting in. I'll switch that over. If anybody has any questions for any of us, by all means, feel free to drop us a line. If anybody has any interest in trying out Carlson software, you'd like more information, maybe you'd like to request a demo copy or whatever, you can try it out yourself. By all means, just let us know, and we'll make it happen for you. So, does anybody have any questions? Anything that we can share with you in the interim before we conclude on Friday? No? All right. Well, I appreciate everybody's time, and there'll be a copy of this available on our Dropbox. If anybody'd like to review this meeting or share it with somebody else, I can make it available to you. Just drop me an email, and you'll have a copy of it. So I guess we'll adjourn. There'll be another one come up. I'll probably invite Lizard Tech the Friday after next to be present for this as well. And if anybody like to talk about something else, you have our information. Everybody have a great Friday. Enjoy your weekend.